Yes. Thank you, everyone, students, for your introduction. Good evening once again, everyone. Welcome to free online coaching for Polycet and Mjprjc set. So now I would like to invite Arun sir to start the session.
Thank you, ma'am. Thank you so much.
Thank you, sir.
Just a second, students. I would like to share another screen. All right, students, let's quickly revise important points from the chapter Electromagnetism today. All right, and then let's go for numericals. I mean, numericals in the sense previous year questions and such. All right, so in electromagnetism, what we've got importantly is this experiment. Students, experiments ఇంకా యాక్టివిటీ మనం మేము చేపిస్తాము అంటే చేస్తాము. మీరు సబ్స్క్రైబ్ చేసుకుంటే యూట్యూబ్ ఛానల్లో మీకు అలర్ట్ వస్తుంది. Soon we are going to perform all the experiments, interesting experiments in both physics and chemistry. So activity అంటే జస్ట్ చదవడమే కాదు, చేసింది చూస్తేనే మీకు క్రియేటివిటీ స్పార్క్ అవుతుంది. Activity sparks creativity. So let's quickly go through the important conclusions of the activities. Students, magnetic field. We use the term field when the force gets applied on an object by another object without being in physical contact. Contact forces ఉంటాయి, non-contact forces ఉంటాయి. For example, gravitational force is a non-contact force. Similarly, that's also a gravitational field. Similarly, you've got magnetic field. It's also a non-contact field. I mean, that will exert a force which is without being in contact with the body. All right. So that's what a field is. And then in this activity 2, where you've got a magnetic compass and a bar magnet, the needle of the magnetic compass is affected by the bar magnet without any physical contact, as I just now mentioned. Physical contact lekundane meeku effect avutundi. So this force causes the needle to deflect and makes it come to rest in certain direction. Our needle emo oka direction lo vachi koncham vibrate ayi aagipotundi. So where is this force being affected from? How is the needle being affected from? Force valla. A force, magnetic force. That is due to the magnetic field of the bar magnet. All right. Students, are you able to hear me? Type yes in the chat box.
It is audible, sir.
It's audible, right, ma'am? Yeah,
Yes,
all
sir,
right, all right. Students, yes, students typing yes. All right. Thank you, ma'am. All right. Students, further నేను మళ్ళీ చెప్తున్నాను, యాక్టివిటీస్ మనం చేస్తూ చూస్తే మీకు క్రియేటివిటీ స్పార్క్ అవుతుంది. So soon we are going to perform experiments in physics and chemistry, not in math course, sorry, physics and chemistry. So నేను conclusions revise చేస్తున్నాను యాక్టివిటీది. So you please subscribe to the YouTube channel if at all you haven't subscribed, so that you get an alert whenever you upload a interesting video. సో మనం ఆ మ్యాగ్నెటిక్ నీడిల్ ని కంపాస్ ని బార్ మ్యాగ్నెట్ నుంచి దూరం తీసుకుంటే స్ట్రెంగ్త్ ఆఫ్ ద ఫీల్డ్ వేరీస్ విత్ డిస్టెన్సెస్ అని మనం కంక్లూడ్ చేయగలుగుతాం. అండ్ ఆల్సో ది డైరెక్షన్ ఆల్సో చేంజెస్. See, you can observe that field exists in all directions around the magnet in 3 dimensions. Magnetic bar magnet ఉంటుంది కదా, దానికి చుట్టూ 3 dimensions లో field exist అవుతుంది. Not only on the plane of the paper, but if I elevate the bar magnet, you can also see that it's being affected. Bar magnet paper మీద లేకున్నా కూడా మీకు field that compass is being affected. ఎక్కడ కంపాస్ ఎక్కడ పెట్టినా మీకు ఎఫెక్ట్ అవుతుంది, నీడిల్ మీద ఎఫెక్ట్ అవుతుంది. Needle will get deflected. So that's why we can say that magnetic field is 3-dimensional. So magnetic field exists in the region surrounding a bar magnet and is characterized by strength and direction. It's a vector quantity, students, basically. Okay. So now let's understand lines of magnetic field. Prati chota manam bar magnet pettesi needle end points manam join chestu velte, I'll get all segments. If I join all the segments, I'll get a loop. That loop is nothing but a magnetic field line. So magnetic field lines and loops, adi conclusion tarvata vastundi. But magnetic field, a field line aina, gravitational field line aina, electric field line aina, magnetic field line aina, is I draw tangents to a curve. నేను ఆ టాంజెన్స్ ని కలిపితే నాకు ఒక కర్వ్ వస్తుంది. ఆ కర్వ్ ని ఫీల్డ్ లైన్ అంటారు. ఫర్ ఎగ్జాంపుల్ హియర్ ఈ బ్లూ లైన్స్ ఉన్నాయి కదా, ఆ ఫీల్డ్ లైన్స్ అంటారు. బ్లూ లైన్స్ ఫీల్డ్ లైన్స్ అంటారు. టాంజెంట్ డ్రా చేస్తే ఐ గెట్ ద డైరెక్షన్ ఆఫ్ ద మ్యాగ్నెటిక్ ఫీల్డ్ అట్ దట్ పాయింట్. సో హౌ విల్ ఐ గెట్ ద డైరెక్షన్ ఆఫ్ మ్యాగ్నెటిక్ ఫీల్డ్? టాంజెంట్ డ్రా చేస్తే. స్ట్రెంత్ ఎలా కంక్లూడ్ చేయగలుగుతాను? ఇఫ్ ద ఫీల్డ్ లైన్స్ ఆర్ క్లోజర్, strength is more. If the field lines are far apart, the strength is less. That's a qualitative conclusion, students. అంటే mathematical conclusion కాదు, qualitative reasoning based conclusion that field lines closer ఉంటే, field lines in the like near the poles, strength is more. Away from the poles, for example on the equatorial line, field lines far apart ఉంటే, strength is weak. All right, so these lines are called magnetic field lines. Field lines are imaginary lines, students. These lines help us understand the nature of the field. So if you place a compass at any point on the line, the needle comes to rest along the tangent to the line. ఇప్పుడు చెప్పాను కదా, tangent draw చేస్తే that would be the direction of the magnetic field at that point. So we conclude the tangent drawn to the field line at a given point gives the direction of the field. Direction మనం ప్రిసైజ్ గా చెప్పగలుగుతాము ఫీల్డ్ లైన్ ఇస్తే, కానీ మాగ్నిట్యూడ్ వైజ్ మనం ప్రిసైజ్ గా చెప్పలేము, ఓన్లీ రిలేటివ్ గా చెప్పగలుగుతాము. ఇక్కడ మాగ్నిట్యూడ్ ఎక్కువ ఉంది, ఇక్కడ మాగ్నిట్యూడ్ తక్కువ ఉందని. క్లోజర్ లైన్స్ ఉంటే ఎక్కువ ఉంది, వైడ్ అపార్ట్ ఉంటే తక్కువ ఉందని. బట్ direction we can precisely tell if you know the field line. All right. Usually field lines may not be closed, but for magnetic field lines are always closed loops. That has got far-reaching consequences, students. Field lines, magnetic field lines are always closed loops. All right. Let's go for the next point. Okay, as I just now mentioned, in some places field lines are crowded as near the poles, and in some places field lines are spread apart. For example, at the far distances from the magnet. So when the field lines are crowded, the field is strong. When the field lines are spaced apart, the field is weak. That is a qualitative picture we can get about the magnitude of the field. But the direction, we can precisely get the direction by drawing a tangent to the field line. So nature of the field is characterized by two things, strength and direction. It is said to be non-uniform when strength or direction changes. Strength aina direction and change aithe, it's called non-uniform. That's called uniform. This is an important question repeatedly asked in RJC set. It is called uniform when the strength and direction is remaining same throughout the space. Then it's called uniform field. For example, this is a uniform field, students. Ikkada right picture undi kada, parallel lines unnai, they are spaced equally. That means my magnitude is remaining constant and the direction is always towards right. So direction is also remaining constant. So this is a uniform field. But whereas for this one, bar magnet, look at this. They are closely spaced here, far apart, spaced apart here. So magnitude ikkada vere undi, magnitude ikkada vere undi. If I draw the tangent, direction of tangent is going on changing along the field line. So field line, this field is non-uniform field. Uniform field ఒకటే pattern ఉంటుంది students. ఎప్పుడు చూస్తే uniform field ఇలానే కనిపిస్తుంది. We'll have no other pattern picture of uniform field other than this. They should be equally spaced and constant in direction, constant in magnitude and constant in direction. All right, now let's talk about flux. Flux is nothing but the number of field lines passing through a plane area A perpendicular to the field. The field lines ila right side and towards this direction and if I take a plane like this, if I take a plane like this, so field line, number of field lines cutting through this one is called flux. Cutting through, that's the important word, cutting through. Then ila pattern and is any field line cutting through this one? No, field lines are grazing through this one. So the flux is zero. ఇప్పుడు flux non-zero ఉంటుంది, ఎందుకంటే cutting through ఉన్నాయి. But if I place it like this, field lines are grazing through this one. Grazing. So field lines are not cutting through the surface area. So flux is zero. That's an important question, students, in RGC set. So it depends on the orientation of the plane. Flux depends on the orientation of the plane. Students, are you able to follow what I'm speaking? Type yes in the chat box. Yes or no? I've highlighted a few points. All right, good, good, good. I want everyone to respond, students. There are still 10 more students who haven't responded. Sorry. All right, good, good. Let's go forward. So flux depends on the orientation of the plane. That's very important. Field lines ఇలా ఉంటే we are talking about only uniform field lines at this level. మీ 10th level లో uniform field lines గురించి మాట్లాడితే ఒక ప్లేన్ ఏరియా ఇలా తీసుకుంటే field lines are cutting through this one, so there is flux is non-zero, zero లేదు flux. But as I go on changing, flux is going on changing. Why? Number of field lines cutting through the area are changing. When the plane becomes parallel to the field line, flux is zero because field lines are grazing through the surface. They're not cutting through. They're grazing the surface. So flux is zero. So that's a very important point here, students. Over here, yeah. All right, and the SI unit of the magnetic flux is Weber. The strength of the field is technically called the magnetic flux density. So magnetic flux density is defined as the magnetic flux passing through unit area taken perpendicular to the field. All right. We can define for different angle theta also at intermediate level. But right now we can talk of field lines and an area perpendicular to the field. That's how we define flux and magnetic field flux density. So let the flux be phi. It's denoted by phi, 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 Greek letter phi. This is called capital phi. In Greek, it is called capital phi, phi, phi. Now let's do it mathematically. Let's treat the let's look at the treatment which is mathematical. B is equal to phi by A. So units of magnetic flux density is Weber per meter square. Phi is in Webers, area is in meter square. So that's Weber per meter square. Makes sense. And this is also called Tesla. All right, in honor of the scientist Tesla, Nikola Tesla. All right. Now here is student more generalized formula for the orientation when the orientation changes. The orientation change అయినప్పుడు నేను ఫ్లక్స్ ఎలా రాస్తాను? ఇలా ఉన్నప్పుడు నేను ఎలా రాస్తాను? B is equal to phi by A అని రాస్తాను. కానీ ఇలా orientation change అయినప్పుడు నేను రాయగలుగుతాను, but that's more detailed. Where you have got phi is equal to BA cos theta. ఈ BA cos theta in-depth meaning మనకి intermediate లో ఉంటుంది. That's very beautiful treatment. చాలా బాగుంటుంది. You'll take a shadow actually. ఇది లైట్ రేస్ అనుకొని ఈ బాడీని షాడో తీసుకుంటాం. ఇక్కడ ఈ షాడో ఏరియాని మనం మాట్లాడతాం. షాడో ఏరియాతో మనం విల్ డీల్ విత్ దట్ మ్యాథమెటికలీ. That's beautiful. Wherever you get A cos theta, we talk of shadows in physics. All right, look at the statement. Green line తో highlight చేశాను. What is the flux to the plane taken parallel to the field? Tell me the answer, students. What is the flux to the plane taken parallel to the field? I just now discussed this one. Can you type the answer? Is it zero or non-zero? Options are zero or non-zero. Excellent, Gayatri. Gyaneshwar, excellent. Yeah, I want more answers. Yes, I'm getting answers now. Yes. Monica. Okay. All right. Now number names are scrolling faster than I can read. Good. I cannot read all the names, but I'm getting. Okay, one answer is wrong. I'll tell you again. See, plane ఇలా ఉన్నప్పుడు నాకు field lines are cutting through. See, I'm piercing the paper, this book. This plane అనుకుంటే, ఈ field line అనుకుంటే, I'm piercing the book. కానీ ఇలా plane change అయినప్పుడు, angle change అయినప్పుడు నేను pierce చేస్తున్నాను. కానీ ఇలా horizontal అయిపోయినప్పుడు field line ఇంకా this plane is parallel అయినప్పుడు graze చేస్తుంది. So I'm not cutting through the book, but I'm just grazing the book. Appudu field line is flux is zero. All right, Saivardhan, you got the point now. I hope you got the point now. Yes, Ganesha, that's right. All right, let's go forward. All right, magnetic field due to currents. See, current carrying wire produces magnetic field. How could we observe that? How could we conclude that? Okay, wire which current pass cheste, if I bring a needle towards it, it's being affected. It's being influenced. That means this magnetic needle is being influenced because of the magnetic field produced around the current carrying wire. All right. Yesterday in a book, that book, Principles of Physics, Resnick and Halliday, I've shown this experiment. That experiment is again conducted in intermediate also, but with the iron fillings. ఇది కూడా మేము చేసి చూపిస్తాము. Soon we're going to do it. If you haven't subscribed to this YouTube channel, please subscribe. I'm telling this again because you go alert ostundi. Otherwise, you might miss the video. And they are interesting video, students. All right. Now let's look at the shape of the field line around a long straight conductor. Long straight conductor is very important. All right. Well, what is the shape of the magnetic field line around a wire? It must be circular line. So we conclude that magnetic field lines are closed lines. Again, magnetic field lines are always closed, no matter what kind of source you take, bar magnet, solenoid, toroid, anything, any source you take, they are always closed. That has got far-reaching mathematical consequences, physical consequences also, which is dealt in intermediate. These are the foundations for the intermediate concept, students. These foundations meeku bar avali. And these are the repeated questions. This question recently ochindi RGC lo. We will look into the question again after this theory session. We'll go for problem session kada. Appudu ee question chustam. Previous year lo ochindi. So this can be verified using by sprinkling iron fillings around the wire when the current flows in the wire. All right. And there is yet another way of concluding, not concluding, deciding what is the direction of the loop using the right hand thumb rule. If I point out, let's say this is the wire. If I point my direction, my thumb in the direction of the current this way, so my curled fingers will tell me the direction of the loop, magnetic field lines around the loop, around the current wire. So if the current is in this direction, it's in this way. When I see from above, it's anti-clockwise. When I see from above, see anti-clockwise or clockwise, మీరు ఎక్కడి నుంచి చూస్తున్నారో చెప్పాలి. Otherwise, it doesn't make sense. ఇది clockwise ఉండొచ్చు, anti-clockwise ఉండొచ్చు. ఇది clockwise, ఇది anti-clockwise అనుకుంటే కింద నుంచి చూస్తే clockwise, పై నుంచి చూస్తే anti-clockwise. So that's important that you mention ఎక్కడి నుంచి చూస్తున్నారు. So right hand thumb rule gives you direction of field lines. All right. This was a circular coil. Here also you've got right hand rule, but not a thumb rule, where if I curl my fingers in the direction of the current, okay, ring ila undanukunte, if I curl my fingers in the direction of the current, my thumb will give me the direction of the field line at the center. All right, this way, figure 5b. If I curl my fingers in the direction of the current, my thumb gives me the direction of the magnetic field at the center. All right. So when you curl your right hand fingers in the direction of current, thumb gives the direction of the magnetic field. Students, these are all mnemonics, visual mnemonics. Mnemonics are some kind of way to remember how to conclude magnetic field lines. But if you go into deeper into the depths of the subject, we will not be using these rules. We will be dealing with this mathematically. Mathematically treat chesi, we will conclude all these points. ఇప్పుడు ఈ 10th లెవెల్ కాబట్టి రైట్ హ్యాండ్ రూల్, రైట్ హ్యాండ్ థంబ్ రూల్, ఫ్లెమింగ్స్ లెఫ్ట్ హ్యాండ్ రూల్ ఇవన్నీ అంటే వాడతాం. బట్ దీస్ ఆర్ ఆల్ కాల్డ్ స్క్రూ క్యాల్కులస్. క్యాల్కులస్ యూజ్ చేసి వాడతాం, మనం చెప్తాం. ఎనీవేస్ దట్స్ ఇన్ ఇంటర్మీడియట్. జూన్ లో స్టార్ట్ అయినప్పుడు మనం డిస్కస్ చేద్దాము. ఆల్ రైట్. ఫర్ ఎ సోలెనాయిడ్, యాజ్ ఐ టోల్డ్ యూ, నో మ్యాటర్ వాట్ ద సోర్స్ ఇస్, magnetic field lines are closed loops. ఇక్కడ చూడండి డయాగ్రామ్ లో క్లోజ్డ్ లూప్స్ ఏ ఉన్నాయి. So it's not, so what is a solenoid? Long wire wound in a closed packed helix. That's a solenoid. All right. Now look at this important point. Magnetic field lines set up by a solenoid resemble that of a bar magnet, indicating that solenoid behaves like a bar magnet. All right. Now that means it resembles a bar magnet. It is not a bar magnet, but it resembles a bar magnet. So for experiments, you can use this to treat. If you only want to conduct some experiment on using solenoid or bar magnet, the result is going to be similar because both are behaving similarly. All right. So one end of the solenoid behaves like a north pole, the other behaves like a south pole. Field lines of the solenoid are continuous with those inside. Outside the solenoid, the direction of the field lines is from north to south. Important point. While inside, the direction is from south to north. So thus the magnetic field lines are closed loops. And this is the case of bar magnet too. Bar magnet lo kuda baita north to south untundi. Lopala south to north untundi. Now, what is inside a what happens in a current? What is moving in a current? Charges are moving in a current, right? So charges in motion produce magnetic field. This is again a previous year question. Charges in motion produce magnetic fields. So current produces magnetic field. Experimentally conclude chestam manam Polycet experiment nunchi. But current lo emoutundi, electrons are in motion. That means electrons in motion or charge in motion produces magnetic field. Excuse me. All right. Now this was the sources of the magnetic field. Now let's talk about the force due to magnetic field on a moving charge. All right. Here I've got a magnetic field, uniform magnetic field. In this level, we are talking only about the uniform magnetic field. ఇక్కడ యూనిఫామ్ ఎలా చెప్పగలుగుతున్నాను? స్పేసింగ్ ఈక్వల్ ఉంది, డైరెక్షన్ కాన్స్టెంట్ ఉంది. స్పేసింగ్ ఈక్వల్ ఉంటే మాగ్నిట్యూడ్ సేమ్ ఉంది, డైరెక్షన్ కాన్స్టెంట్ ఉంది, డైరెక్షన్ సేమ్ ఉంది. All right. Now when this is projected, దీని మీద ఫోర్స్ యాక్ట్ అవుతుంది. Magnetic force on the charge is the product of three quantities: speed, charge speed, and magnetic flux density. QVB. You actually have QVB sin theta, but theta over here is 90. So sin 90 becomes 1. Vishwanath, we are not talking of energy now. We are dealing with forces. Energy is later. All right. Let's now, we'll talk about in terms of energy, but we are dealing with forces now. Force on a charge, force on a current carrying conductor when placed in uniform magnetic field. Uniform magnetic field. All right. Important point now again. Previous year question. When charge moves parallel to the magnetic field, along the field or against the field. Field line ila undan kundamu. Idi field lines. Ila unnai. Field lines ila unnai. Ila unnai. Ee direction lo unnai. Then charge emo ila project chestanu along the direction of the field line. Force is 0. The charge will continue to move in the same direction as per Newton's laws. Ila project cheste force 0 untundi. That's what he's saying. When the charge is projected parallel or anti-parallel, parallel or along the field or against the direction of the field, no force acts on the charge. Because sin theta is 0 or 180, sin 0 or sin 180 is 0. All right, thus the charge experiences no force. Here the pink to highlight chesani. No force when it is moving parallel to the magnetic field, that is along the field direction or against the field direction. One more interesting fact about magnetic force. Magnetic force is always perpendicular to the direction of both velocity and magnetic field. Yellow to highlight chesanu last flow. Direction of magnetic force is always perpendicular students to the direction of both velocity and magnetic field. Usually gravitational force ela untundi, mass ela unte, field kinda untundi, force kuda kinda untundi. It's independent of velocity. Nenu ela project chesina force emo kindane untundi, gravitational force. But it's not like that with magnetic field. Nenu ela project cheste dani meeda depend avutundi. Nenu along the field project cheste force 0 untundi. Ila project cheste force verega untundi. Ila project cheste force verega untundi. But in all the cases, force is always perpendicular to the direction of both velocity and magnetic field. Velocity ila magnetic field ila undi, velocity ila field ila undi, velocity ila undi. So B force will be in this direction. Red color pencil is velocity. This is the magnetic field. Force will be in this direction, in the direction of my finger, index finger. All right. Anyways, that visualization will show it to you later. Here is the figure. When I curl my fingers from V to P, my direction of thumb will give me the direction of force. All right. There is another rule again. I told you visual mnemonics. Again, some guide It's actually mathematical treatment, mathematical equation ఉంటుంది, but for that we have got guide using right hand rule, rule, where my middle finger will show me the if I point this in the direction of the B, index finger in the direction of velocity, my thumb will give me direction of the force. All right. If the forefinger points towards the direction of velocity, middle finger points in the direction of the field, then thumb gives the direction of the force when three fingers are stretched in such a way that they are perpendicular to each other. And this is for the positive charge. Again, important question. Negative charge law. Negative charge law ఏమవుతుంది? You find out for the positive charge, then reverse the direction. నేను positive charge కోసం కనుక్కుంటాను. Right hand rule is for the positive charge. But what I do, because it's negative, QEB lo Q negative on the F will be negative of this one. All right. So I reverse this direction. I first find the direction of the force acting on the positive charge, highlighted blue. Next, I reverse this direction. All right. That's the force on the negative charge. Now look at the example, students. It's an important example where we derive time period. Please go through this example. ఇక్కడ మనం circular motion ఇంకా force ని relate చేస్తాము. Centripetal force is equal to mass times centripetal acceleration. F is equal to ma. All right. Now we talked about force on an individual charge, force on a current carrying wire, which turns out to be ILP, highlighted here with yellow. F is equal to ILP. Current, length of the conductor, current through the conductor, length of the conductor, and magnetic flux density. This holds well only when the direction of the electric current is perpendicular to the magnetic field. Important. It's actually ILP sin theta. Theta becomes 90, sin 90 becomes 1, ILP వస్తుంది. Be careful when you apply. If he says parallel to the magnetic field, the current is flowing parallel to the magnetic field, force is 0. But if it's going perpendicular to the magnetic field, then it's ILP. All right. So in general, it's ILP sin theta. నేను ఎగ్జామ్ కోసం ఫార్ములాస్ ఏది ఉంటుంది, పాయింట్స్ ఏవి ఇంపార్టెంట్ ఉంటాయి అవే రివైజ్ చేసి వెళ్తున్నాను స్టూడెంట్స్. మీకు యాక్టివిటీస్ అంటే చేసి చూపిస్తాము, బట్ ఇఫ్ ఆల్ యూ వాంట్ గో త్రూ యాక్టివిటీస్ అగైన్, దట్స్ ఈవెన్ బెటర్. ఆఫ్టర్ దిస్ సెషన్ యూ కెన్ గో త్రూ ది యాక్టివిటీస్. All right, this is the force on a conductor. Again, an activity. Here, student, different kinds of fields are shown. This is a uniform magnetic field, and this is the field due to current, long current carrying wire. Long. Why is long important? Later. But as of now, understand that it's for long current carrying conductor. And this is when you have got a bar magnet and under the influence of a Earth's magnetic field, you'll get such a field lines. All right. Right. Let's go further. Now let's talk about electric motor students, applications. Working of electric motor. Force on current carrying wire is a direct application of, electric motor is a direct application of the force on current carrying wire. A loop on the left yellow box low, uniform magnetic field low. Again, we are talking about uniform magnetic fields only. Uniform ela cheppagalugunnanu nenu, spacing equal undi ante magnitude equal undi, magnitude same undi throughout the space, direction constant undi, so that's why it's uniform magnetic field. Direction and magnitude both should be same for it to be called uniform. If any one of this is different, then it is non-uniform magnetic field. In case of చూడండి, 3 cases లో these two are non-uniform. Center one in the right corner non-uniform, whereas this left corner is uniform. All right, let's go forward. ఇక్కడ స్టూడెంట్స్ ఏమవుతుందంటే AB, BC, CD, AD. This is the current flowing in this coil. All right, it's a coil, rectangular coil. AB మీద force is into the plane. ఎలా చెప్పగలుగుతాను? Same rule. This is my conventional current. Field into the plane. This is my force. Force is into the plane because conventional current upward, magnetic field rightward, my thumb inward. Or ఇలా కూడా చేయొచ్చు. L నుంచి నేను B వరకు నేను కర్వ్ చేస్తాను ఫింగర్స్. నా థంబ్ డైరెక్షన్ ఏమో ఫోర్స్ డైరెక్షన్ ఇస్తుంది. when I curl my fingers from L, direction of current, to the direction of magnetic field, my thumb direction will be in the direction of the force. Similarly, the current opposite అయిపోయింది కాబట్టి force is outward. BC means the force upward. Sorry, what is the force on BC, students? Right now, current is parallel to the magnetic field. Force is zero. Force on BC and AD is zero. Note. ఎందుకు current is in the direction of the magnetic field. Sin 0, 0. ILB sin 0, 0. And ఇక్కడ ILB sin 90 ఉంది. So ILB ఉంటుంది, ILB ఉంటుంది. Direction is inward, outward. But BC ఇంకా AD మీద, BC ఇంకా AD పైన కింద మీద 0 ఉంటుంది force. But as I rotate this one, force will be non-zero. But net force will be 0. Net force 0 ఉంటుంది, but net torque 0 ఉండదు. ఈ rotational effect ఉంటుంది. Translation effect ఉండదు, but rotational effect ఉంటుంది. Net force 0 ఉంటే no translation. Move కాదు. Net force 0 ఉంటే. కానీ net torque 0 ఉంటే rotate కూడా కాదు. కానీ ఇక్కడ net torque non-zero ఉంటుంది. So because it will start rotating. ఇది మనం యూజువలీ క్యాప్ ఓపెన్ చేయడానికి ఎలా పట్టుకుంటాము? ఈ థంబ్ నుంచి ఇలా పుష్ చేస్తాము, ఈ ఫింగర్ నుంచి ఇలా పుష్ చేస్తాము. అయితే క్యాప్ రొటేట్ అవుతుంది కదా, అది రొటేషనల్ ఎఫెక్ట్. కపుల్ టార్క్ యాక్ట్ అవుతుంది. సో హియర్ ఇట్స్ వాట్ హ్యాపెన్స్. What happens to the rotation of the coil if the direction of the current in the coil remains unchanged? అప్పుడు ఏమవుతుంది? ఈ కాయిల్ ఫస్ట్ రొటేట్ అవుతుంది. కాయిల్ రొటేట్ అవుతుంది. ఇది కాయిల్ అనుకుంటే ఇలా రొటేట్ అవుతుంది, మళ్ళీ ఇంకా రొటేట్ అవుతుంది, ఇలా వెళ్ళి ఇలా ఉంది కదా, ఇనిషియల్ పొజిషన్ ఇలా ఉంది, ఫీల్డ్ లైన్స్ ఇలా ఉన్నాయి. సో టార్క్ ఇలా ఉంది. ఇట్ రొటేట్ లైక్ దిస్, acquires some velocity, it go like this, stop here and keeps on oscillating. If the direction of the current is not changed, it keeps on oscillating. It doesn't rotate totally. Okay. That's actually called dipole. Dipole గురించి మనం తర్వాత నేర్చుకుందాము eventually. So as a result, this coil comes to halt and rotates in anti-clockwise direction. First clockwise అవుతుంది, మరి anti-clockwise వస్తుంది. This will go on if the direction of the current remains unchanged. అది ఒకటే డైరెక్షన్ లో తిరగాలంటే నేను డైరెక్షన్ ఆఫ్ ది కరెంట్ రివర్స్ చేస్తాను, అప్పుడు ఒకటే డైరెక్షన్ లో రొటేట్ అవుతుంది. నేను డైరెక్షన్ ఆఫ్ ది కరెంట్ రివర్స్ చేయలేదనుకోండి, అప్పుడు అది ఆ స్పీడ్ పికప్ చేస్తుంది, ఆగిపోతుంది, మళ్ళీ రివర్స్ వస్తుంది, మళ్ళీ ఆగిపోతుంది, మళ్ళీ రివర్స్ వస్తుంది, ఆగిపోతుంది. ఇలా రొటేట్ అవుతూనే ఉంటుంది, ఆసిలేట్ అవుతూనే ఉంటుంది, వైబ్రేట్ అవుతూనే ఉంటుంది. రొటేట్ కాదు, వైబ్రేట్ అవుతూనే ఉంటుంది. Next is how do you make it continuously rotate? In that case, what do you do? You use such an arrangement, slip rings and all. This arrangement has to be shown, students. Otherwise, you please go through this diagram. Ikkada slip rings untai, commutator untundi. So current reverses every time, every half an oscillation. Current reverses, because of which torque remains steady. Torque opposite direction lo unte rotate avutune untundi. All right, let's go for another activity, students. Electromagnetic induction. We talked about the sources of the magnetic field. We talked about uniform magnetic field, non-uniform magnetic field. Then we talked about the effect of magnetic field on a moving charge and effect of magnetic field on a current carrying conductor, QBB and ILB. F is equal to QEB for charge projected in a uniform magnetic field. F is equal to ILB for a current carrying conductor in a uniform magnetic field, perpendicular to the magnetic field. I repeat, if the charge is projected in the direction of the magnetic field, direction of the magnetic field, no force acts on the charge. Similarly, if there is a current carrying conductor in the direction of the magnetic field, no force on the conductor acts. All right, let's go for induction now. Induction is something which is happening at a distance. I have a coil. ఇది ఈ కాన్సెప్ట్ ఎంత ఇంపార్టెంట్ స్టూడెంట్స్, ప్రీవియస్లీ ఐటీజేలో కూడా వచ్చింది క్వశ్చన్, చాలా సార్లు వచ్చింది ఐటీజేలో. ఈ క్వశ్చన్ ఐటీజేలో చాలా సార్లు వచ్చింది. ఐ పుట్ ఏ క్వశ్చన్, ఆర్జీసీలో కూడా వచ్చింది, ఐటీజేలో ఇంకా కొంచెం డెప్త్ ఉంటుంది, బట్ సేమ్ కాన్సెప్ట్ మీద ఐటీజేలో కూడా వస్తుంది, రిపీటెడ్లీ వస్తుంది. సో దిస్ కాన్సెప్ట్ ఇస్ వెరీ బ్యూటిఫుల్, మోస్ట్ డిఫికల్ట్ ఆఫ్ ఆల్ ద ఫిజిక్స్ కాన్సెప్ట్స్ టు అప్లై అండ్ మోస్ట్ రిపీటెడ్లీ ఆస్క్డ్ ఇన్ ది ఎగ్జామ్. This is one of the most beautiful topics in the whole of physics, students. Electromagnetic induction. Then comes rotational dynamics. You don't know most difficult and most interesting. And students, please fill up the form. I noticed that students are not filling up the form. Do fill up the form, students. Koncham effort pettandi. See, we are all doing this for your good. So we need to maintain a record. For that, you have to fill up the form. It will hardly take a minute. Do fill up the form, students. It's a sincere request from my side. Koncham cooperate cheyandi. We are doing this for your good. If you fill up the form, we'll get to know more details. We'll be able to better perform. We'll be able to better design our sessions. All right, please fill up the form. If at all you haven't filled up till now, please fill up the form. All right, now I've got a coil and a bar magnet. Good, Vishwanath. If you have done, good. But if for the ones who have not done, there are students who have not done. So for those students, I'm telling you, please do fill up the form. All right, now I've got a coil. I've got a coil. It's a rectangular coil I'm showing. In book of circular coil chupicharu. I've got a coil. I've got a bar magnet. Let's say this is north, this cap is north, and this is south. And I take this towards this one. What happens, what is noticed is when I connect an ammeter to this one, how do I measure current? Ammeter, right? So when I measure the current for this one, when I just move this one without any battery in this one, without any source in this one, source of EMF in this one, if I just move this one, as long as I move this, there is some current observed in this one. As long as there is motion here, there is some current observed. What do you call stopping? If I stop it here, pardon me for my Telugu students. ఇక్కడ ఆపేస్తే ఇలా మూవ్ చేసి ఇక్కడ ఆపేస్తే కరెంట్ కూడా ఆగిపోతుంది. That's one thing. If I move the coil, instead of keeping this bar magnet steady, if I move the coil, again current notice అవుతుంది. Current being observed. Or if I move both together like this, with relative motion 0, రెండు constant గా వెళ్తుంది, steady గా వెళ్తుంది. Even then no current is observed. They are moving, but no current is observed. If one moves, current is observed. If this moves, current is observed. But if both move like this, no current is observed. But if both move like this, current is again observed. Ante relative motion unte current is being observed. That means if there is, so that point is highlighted here, the relative motion of the magnet and coil set up a current in the coil. It makes no difference whether the magnet is moved towards the coil or coil is moved towards the magnet. All right, so relative motion is important. Rendu kalsi move aithe, no current. If only this moves, yes, current. But as long as this moves, the moment I stop it, no current. As long as this moves, there is current. The moment I stop it, no current. So what is happening is we think in terms of flux, rate of change of flux. All right, more on visualization of flux. We'll make another video on that. Flux, ela visualize chestaru. But as of now, think in terms of flux. Flux enti number of field lines or field lines cutting through an area is flux. Right, number of field lines cutting through an area is flux. More the number of field lines cut through an area, more is the flux. Cutting through change aithe flux change avutundi. Flux change aithe rate of change of flux untundi with respect to time. So here is Faraday's law. Whenever there is a continuous change of magnetic flux linked with a closed coil, a current is generated into the coil. Coil lo battery em ledu, coil lo source of EMF em ledu. But without that any source of EMF, I am able to produce current in the coil just by moving a magnet, or in other words, just by changing the magnetic flux. As long as there is change in magnetic flux, as long as there is a continuous change in magnetic flux with a closed coil, linked with a closed coil, there is a current in the coil. That's Faraday's law. Qualitative statement of Faraday's law. Mathematical statement is over here, students. The induced EMF generated in the closed coil is equal to the rate of change of magnetic flux passing through it. In mathematical form, we have got change in flux per unit time. All right, delta phi by delta t. This equation is called Faraday's laws of induction, where phi is the flux linked with the coil. All right. Now, current aithe undi. That's what we have concluded. Ela conclude chesaru? Ammeter measurement వచ్చింది, current వచ్చింది. But now direction of current, it's also noticed in magnet ni towards the coil తీసుకుంటే ఒక direction లో వచ్చింది current. Needle in diameter turned in one side. If I take it away, current is in other reverse direction, other direction. So this is also concluded. This is also noticed in the experiment. So there's another law for this one to conclude this direction to current. That's Lenz's law. Lenz's law is a qualitative law, students, in physics. Qualitative అంటే దానికి mathematical statement ఉండదు, just reasoning based statement ఉంటుంది. There are different kinds of law, students. అది తర్వాత మాట్లాడదాము, but Lenz's law is a qualitative law. All right, so here is what we do. In simple terms, when flux increases through the coil opposes the increase in flux. When flux decreases through the coil, it opposes the decrease in flux. In the North Pole, when I move towards the coil, like this, flux field lines are increasing, which are cutting through this coil. Field lines ఎలా ఉన్నాయి ఇక్కడ? Field lines ఎలా ఉన్నాయి? ఇలా ఉన్నాయి. ఇది నార్త్ అని ఉంది కదా, golden point నార్త్ కదా, ఇలా ఉన్నాయి field lines. ఇక్కడ dense ఉన్నాయి, ఇక్కడ spaced apart. So ఇక్కడ magnitude ఎక్కువ ఉంది, ఇక్కడ తక్కువ ఉంది. As I go far, magnitude is less. So if I have a coil, if I move this towards the coil, field lines are which are cutting through are increasing. So flux is increasing. There is a change in flux. నేను దూరం వెళ్తే flux is decreasing. There is a change in flux. That is what is being opposed. All right. More on that, again, a demonstration later. Students, are you able to follow what I'm speaking? Please type yes or no in the chat box. All right. Okay. All right. All right. Thanks for the response. Good. So everyone is here. All right. Good. Thank you, students. Here's the mathematical treatment of this one. That's data not required right now. Here, most important example, students. The example chala important. Repeatedly vasundi. Flux is changing this way as the graph is shown. First increasing, then remaining constant from 0.1 to 0.4 seconds. Sorry, 0.1 to 0.3 seconds. 0.3 నుంచి 0.45 seconds వరకు decrease అవుతుంది. So he's asking, is there any change in induced EMF from 0.1 to 0.3 seconds? ఇక్కడ ఈ horizontal line ఉంది కదా, pink line, అక్కడ change ఉందా? Change in flux ఉందా? Change in flux లేదు. EMF is nothing but rate of change of flux. Student, please don't hesitate to express yourself. Student, knowledge is important కాదు, express చేయడం కూడా రావాలి. All right, please express yourself more clearly. That's okay. But here we are here to help you out. మీరు ఎలాంటి query పెట్టినా we'll respond to that. Any query you have got, please WhatsApp it to the 9642215226. All right. All right, let's go forward. So ఇక్కడ హారిజాంటల్ లైన్ ఉన్నప్పుడు ఫ్లక్స్ చేంజ్ కావట్లేదు. ఫ్లక్స్ చేంజ్ కావట్లేదు అంటే రేట్ ఆఫ్ చేంజ్ ఆఫ్ ఫ్లక్స్ జీరో. ఫ్లక్స్ కాన్స్టెంట్ ఉంది. ఇలా పెట్టాను, నార్త్ పోల్ ఇలా పెట్టాను, ఫ్లక్స్ కాన్స్టెంట్ ఉంది, ఫ్లక్స్ చేంజ్ కావట్లేదు. కానీ స్టార్టింగ్ లో ఇలా దగ్గర తెచ్చాను, మళ్ళీ ఇలా పెట్టాను, మళ్ళీ దూరం తీసుకెళ్లాను. ఆ గ్రాఫ్ ప్రకారం ఇలా ఉంది. ఆ గ్రాఫ్ ఎలా అవుతుందంటే, ఫర్ ఎగ్జాంపుల్ ఐఎమ్ నాట్ యూజింగ్ బార్ మ్యాగ్నెట్ ఎందుకంటే లీనియర్ ఉంది. అక్కడ బార్ మ్యాగ్నెట్ ఎగ్జాంపుల్ చూపిస్తే ఫస్ట్ దగ్గర తెచ్చాను 0.1 seconds వరకు, మరి అక్కడే పెట్టాను 0.3 seconds వరకు, మళ్ళీ వెనక తీసుకెళ్ళాను 0.5 seconds 4-5 seconds వరకు. గ్రాఫ్ ఎలా వచ్చింది? నేను అక్కడే పెట్టానంటే ఏంటి? ఫ్లక్స్ చేంజ్ అవుతుందా? చేంజ్ అవ్వట్లేదు. Whenever there is no change in flux, EMF induced is zero. So from 0.1 to 0.3 seconds, EMF induced is zero. But whereas in different times from 0 to 0.1 to 0 to 0.1, delta phi by delta t, E is equal to delta phi by delta t. And he said there are 400 turns. 400 turns unte number of turns, for every turn you have got delta phi by delta t. So more the number of turns, more is change in flux. And times delta phi by delta t. N is 400 into delta phi enta undi 0 to 0.001 varaku change ayindi. So I plug in the values. You just substitute the values, you'll get EMF, which is turning out to be 4 volts. Example 2, students, important example. Find the length of the conductor which is moving with speed 10 meters per second in a direction perpendicular to the direction of the magnetic field. If it induces an EMF of 8 volts between the ends of the conductor. Ante, I know the formula to be applied. PLV, EMF is equal to PLV. Everything is given except L. E is given, B is given, V is given. L is not given. All you have to do is, but when can you apply this formula? When it is perpendicular to the direction of the field. And that is also mentioned. Okavela parallel unte, force is 0. Note, that could be the question. There was a question, such question before. There could be a question again. Parallel to the direction of the field current unte, force is 0. Perpendicular to the field unte, BLV. Some other direction, BLV sin theta, but not required. All right. So when you plug in the values, you'll get L is equal to 1 meter. And there are some application students, security check, ATM, tape recorder, induction stove. And here is the last one. This important magnetic levitation, beautiful experiment, beautiful demonstration, not an experiment, demonstration. We are soon going to demonstrate this one. I've got a coil through which I'm passing an AC current. All right, AC source on there. What I do, I take a metal ring తీసుకొని ఇలా స్లైడ్ చేస్తాను. జస్ట్ కొంచెం డయామీటర్ కొంచెం ఎక్కువ ఉంటే ఇది కాయిల్ అనుకుంటే ఇలా వాండెడ్ అరౌండ్ ది వుడెన్, ఇది కింద వుడెన్ బేస్ ఉంది, ఇది సాఫ్ట్ ఐరన్ సిలిండర్ ఉంది, గ్రే కలర్ ది. రెడ్ కలర్ వైర్స్ ఏమో కాయిల్ ఉంది, కాపర్ వైర్. when I take the ring ని ఇలా స్లైడ్ చేస్తే that will levitate. ఆల్రైట్, కొంచెం వైబ్రేషన్ ఉంటుంది బట్ that will levitate. DC కరెంట్ పాస్ చేస్తే సడన్ పుష్ అవుతుంది. DC కరెంట్ పాస్ చేస్తే. ఆల్రైట్, అది చూస్తేనే బాగుంటుంది స్టూడెంట్స్. ఒకసారి మీరు చదవండి, చదివేసి రెడీ ఉంటే వీల్ పోస్ట్ ద వీడియో ఆన్ ద యూట్యూబ్ ఛానల్. మీరు సబ్స్క్రైబ్ చేసుకుంటే you'll get an alert. You can watch the video. All right, students, with this, let's conclude the theory part. Let's move on to this problems, previous year questions. Are you all ready for the questions now? Type yes in the chat box. All right. Good. Good response. Keep the energy high, students. We need some more time for problems. Keep the energy high. Thank you. Just a second, I'm sharing the screen. Here's the first question, students. In the previous year RGC question, magnetic field lines in the figure indicates circular loop on nine. So read the statements. If there is no flow of current, then only magnetic field lines form around the conducting wire. Current lekunte magnetic field ostunda raadu. All right, good. Getting the answers already. Excellent. But my bad, I released the key. I don't know if you have noticed it. Students, inka students unnaru, attendance form fill up cheyaledu. Kumari, these are the students who have filled the attendance form. Kumari, Faisal, Vishwanath, Nandini, Saivardhan, Mitra Teja, Sahiti, Banotriya, Harshita, Ashwini, Geeta Devi, Akhilesh, Nitik, Sandhya, Shiva, Taruni, Gautami, Gyaneshwar, Venkatesh. But there are students who haven't filled the form. Harish, you didn't receive the link. Hanish, it was just put in the group chat box only. We'll again send it in a while. In a minute, Mali Pampistamu. Hanish, you'll receive the link just in a minute. In a minute, Mali link Pampistamu. And if you're all, you haven't received the link, you'll receive the link again in the chat box. Yeah, here is the link, students. Watching the link. Please fill up the form. Those who haven't filled up the form, please fill up the form. That is important for us to gather the information, students, so that we can better ourselves. We can reach more people. We can redesign our sessions for your good. All this is for your good. Yes, Ivardhan, you have done it. I've seen it. All right, let's go forward. All right, so I've got the answers, but I want everyone to answer, students. Under MCND. There's so many students, but they're still not answering. There are students who are not answering. Around 10 to 12 students are not answering yet. Okay, Sandhya, Pavani, Saivardhan, Agnivesh. Okay, Agnivesh has got a different answer. Monica. Excellent, good. Yeah, good response. And almost all are giving the right answer. But there are students who have gone wrong. Okay, so this is the current carrying wire. Let's say current is downward or into the page. మీరు పేజ్ ఇలా చూస్తున్నారు కాబట్టి into the page ఇలా చూపిస్తాను. కరెంట్ thumb direction ఇలా ఉంది. My direction to field line should be clockwise when seen from this side. మీరు చూస్తే clockwise కనిపించాలి. నేను చూస్తే యాంటీ క్లాక్వైజ్ కనిపించాలి. మీరు చూస్తే clockwise. ఇటు నుంచి చూస్తే clockwise. నేను ఇటు నుంచి చూస్తాను కాబట్టి నాకు యాంటీ క్లాక్వైజ్. Alright? Be careful when you mention clockwise or anti-clockwise. That's how you mention into the page or out of the page. All right. Let's go for next one. If you got a previous year question, students, Lenz's law definition, Faraday's law, Ohm's law, or Oersted experiment. The induced current set up in the coil is in such a direction that it opposes the change in flux. Flux increase aithe oka direction untundi. Flux decrease aithe inkoka direction untundi. That is opposing change in flux. Which law is it? Okay, I got almost all are giving me right answers. Excellent students. Gayatri, good. Sandhya, good. Ganeshwar, good, good. There are students who have gone wrong. Swapna, Monica, good. Yeah, there are many names over here. Okay, there are names which have gone wrong. I would not want to read the long names. Names which have gone wrong. Right. Gayatri is done. Monica, Saivardhan, Ganeshwar. Anyway, I've read the names. Agnivesh, Pavani, Vishwanath, Saivardhan, Mohammed Faisal, Pavani. All right, all right. Now let me release the key. It's Lenz's law, students. All right. This is a previous year question. All right, let's go for the next one. Here, students, here is another question. Let theta be the angle between the direction of current and magnetic field, and it is 90 degrees. Then force acting on the current carrying wire is given by 90 degrees is one special case, students. F is equal to what? Is it F is equal to I by LB? Is it 0? All right, all right. Okay, student 0 చెప్పారు. 0 కాదు student. 0 ఎప్పుడు అవుతుంది? When the current is parallel to the magnetic field. But he said current is perpendicular to the magnetic field. That's very important. ఆ క్వశ్చన్ కూడా వచ్చింది ఇంతకు ముందు. Yes, Meenakshi, Vanotriya, Gnaneshwar, Monica, Gayatri, Hanish. Hanish, I hope you got the form now. Form మీకు లింక్ వచ్చింది కదా? Yeah, good. Please do fill up the form. All right. Take a minute. Do fill up the form. All right. Let's go for the next one. The key is, of course, I have got LB. Everyone has gone right, except one student. All right, Shashank, you want the key link again? All right. Wait for a minute. You'll see the link again. But take note. మీరు chat box లో తొందరగా note చేసుకోవాలి. అంటే లింక్ ఇప్పుడు పంపిస్తాం. Within a minute, you'll send it again, Shashank. Attendance sheet link పంపిస్తాము within a minute. All right, let's go forward. Let's go for the next one. All right. Shashank, you will get the link within a minute. Don't worry. Attendance form link మళ్ళీ వచ్చేస్తుంది మీకు. Yeah, here's the link. Shashank, you got the link? Yeah, good. Please take a minute to fill up the form. All right. Oh, before I read the question, I'm getting answers. Most welcome, Shashank. That's okay. All right. There's a confusion also. That's okay. See, which of the following exists in the region surrounding a bar magnet and is characterized by strength and direction? Bar magnet, around the bar magnet, we don't have electric field, students. And electromagnetism doesn't make sense. So magnetic field, electromagnetism, none. So you have got magnetic field around the bar magnet, which is characterized by strength and gas. So that's right. Option 1 is absolutely right, students. Good. Yes, yes, everyone is absolutely right. Good, good, good. Let's go for the next one. Students, we are falling short of time, so I'll go a little faster. If at all we have to discontinue, we'll continue tomorrow. But as of now, let's continue as fast as we possibly can. Dash law gives direction of induced current. Newton's law, Lenz's law, Faraday's law, Nobel's law. There's nothing called Nobel's law, students. Excellent, excellent. I'm getting right response. Consistent response and faster response. Excellent, good students. Direction of induced current, students. Not the EMF induced, not the magnitude, only direction. It's Lenz's law, students. Faraday's law tells you about the EMF induced. All right. Lenz's law will tell you direction of the induced current. All right, let's go for the next one. When a current carrying wire of length L is placed in the magnetic field P, then the force experienced by the wire is. Quick response, students. We have just now done it. F is equal to LB, IB, ILB, I by LB. Yeah, L. There has to be L, right? In option 2, there is no L. He's talking about L. L is not 1. Okay, Pavani has got a confusion. That's okay. Yes, it's ILB, students. 3 is absolutely right. Most of the students have answered 3. Let's go for the next one. Tappu paina vallu, please correct cheskondi. All right. The motor converts dash energy to dash energy, mechanical to electrical, electrical to light, electrical to mechanical, all the above. A motor. Correct. Consistent response. All right, let's put the key. Yes, excellent. Excellent, students. Keep the energy high. You've got to go a little faster. Keep the energy high. Being consistent. I really appreciate everyone. All right, let's go to the next one. Electromagnetic induction was proposed by factual question, students. I'll release the key. It's just a factual question. No reasoning in it. No science, no physics in it. It's Faraday. All right. It's 2. All right, good. This also you've gone right. Good, 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 students. Appreciate that. Next one. Look at this. This is a good one. If a conductor with 3 amperes current kept in a 0.3 Tesla magnetic field, making an angle of 30 degrees is dash. He's talking about the force on the conductor, students. Force అడుగుతున్నారు, యాంగిల్ ఇచ్చారు, మ్యాగ్నెటిక్ ఫీల్డ్ ఇచ్చారు, కరెంట్ ఇచ్చారు, కానీ లెంత్ ఇవ్వలేదు. లెంత్ ఇవ్వలేదు, స్టూడెంట్స్. ఎస్, నౌ యూ గాట్ ద రైట్ ఆన్సర్. ఐ గేవ్ యూ హింట్, యూ గెటింగ్ ద రైట్ ఆన్సర్. కానీ స్టూడెంట్స్ 30.9 ఎలా వస్తుంది మీకు? కొంతమంది 30.9 ఇస్తున్నారు, 39.9 ఆప్షన్ 3 ఎలా వచ్చింది? మీరు don't go based on memory, students. That's very risky. In physics, that's very risky. Memory will cheat you sometimes. The ones who have answered 30.9, I would like to know how you got 30.9. All right, let's go to the next one. Yeah, option 4 is absolutely right. Because length of the conductor is not given. It depends on the length of the conductor as well, right? F is equal to ILB. I icharu, B icharu, sin theta icharu, but L is not given. All right, let's go for the next one. Magnetic lines of force move from dash pole to dash pole, north to south, south to north, center to north, center to south. All right, specifically they are asking for a bar magnet. North to south, that's right. But outside the bar magnet, they are north to south. Inside the bar magnet, they are south to north. All right, be careful. Yes, option 1 is absolutely right. Inside south to north, outside north to south. అది కొంచెం specific గా లేదు question, but if at all the question were to be inside, then it is south to north. Outside, north to south. All right, let's go to the next one. Magnetic field lines are dashed lines. Closed lines, open lines, circles, ellipses. It's not eclipse, students, ellipse, or the ellipses. Yes, one. Consistent response, one. Now most students are answering the questions. Good, I appreciate that. But there are still students who are not answering. Around 10 students are not answering. Okay, they are closed lines. Absolutely right. Circles, they are special case students. Open, eppudu kaadu. Ellipses vastundi, but there's a special case. But in all the cases, they are closed lines. Closed line, being closed is the property of magnetic field lines. And that has got far-reaching consequences, both mathematically and physically. All right, here's the next one. Direction of lines of force in the outer side of the solenoid is. ఇప్పుడే మనం మాట్లాడాము. Outer side, inner side. Outside, inside. Outside, it's from one to something. Inside, from something to something else to something else. Yes, outside is north to south. Excellent. It's inside, it's south to north. Sandhya, it's south to north inside, students. Inside unnappudu south to north, outside unnappudu north to south. All right, here is another question, formula based. No, you just asked me the formula. అది ఎగ్జాంపుల్ నేను మనం డిరైవ్ చేయలేదు కానీ ఎగ్జాంపుల్ చూసాం చూడండి స్టూడెంట్స్. ఇఫ్ క్యూ ఇస్ చార్జ్ పార్టికల్, సెంట్రిపిటల్ ఫోర్స్ ఈజ్ ఈక్వల్ టు మాస్ టైమ్ సెంట్రిపిటల్ యాక్సలరేషన్ అని చెప్పాను. ఆ ఫార్ములానే టైం పీరియడ్ డిరైవ్ చేశారు. అక్కడ టైం పీరియడ్ ముందు రేడియస్ కనుక్కుంటారు. ఇస్ గోయింగ్ విత్ స్పీడ్ v in v induction field, then the radius is r is equal to mb by qb, mb by qb, mq by bb, none. mb by qb, okay. This I suggest you remember the formula, students. Derivation ఒకసారి చూడండి ఆ పేజ్ నెంబర్ లో, ఎగ్జాంపుల్ లో చూడండి. Yes, Kumari, that's absolutely right. MB by QB is right. Option 2 is absolutely right, students. Good. Most of you have gone right. కొంతమంది తప్పు వెళ్ళారు, that's okay, but correct yourself. All right. We are in phase 2, students. Phase 2 of competitive exam. We have crossed one battle, 2 more battles to for the war to be over. This war is on. All right, let's go for the next one. Here is the numerical, students. If a 50 centimeter or 0.5 meter long conductor is moving at a speed of 4 meters per second in a 3 Tesla inductive field, uniform, look at that, uniform, then the induced EMF is ILB. I told you the answer. Use the formula ILB. Be careful with the calculation, students. Physics of the problem is F is equal to ILB. Rest is simple math. As I always tell, I again tell you, there are 2 aspects of a problem. Physics of the problem, math of the problem. Physics of the problem would just say you're strong in physics. But if you go wrong in math, your whole answer would be wrong. So you have to be careful in math of the problem as well. But if physics of the problem is right, that means I really appreciate for the physics of the problem. Physics knowledge you have got. Ria, that's 50 centimeters. Now you think of the answer. That's 50 centimeters, not 50 meters. Ria, please check your calculation now. That's 50 centimeters, not 50 meters. 0.5 meters. You'll get the right answer now. Excellent. Ria, that's excellent. Yeah, most of the students have answered right. But there are students who have gone wrong because 50 centimeters students are 50 meters కాదు. మీరు 50 meters సబ్స్టిట్యూట్ చేసి చేస్తున్నారు, అందుకే 600 వస్తుంది. ఆప్షన్ 3 వస్తుంది. అది 0.5 meters. 0.5 meters సబ్స్టిట్యూట్ చేస్తే మీకు కరెక్ట్ ఆన్సర్ వచ్చేస్తుంది. All right, let's look at the key. 6 volts, absolutely right, students. ILB. I is 4, L is half, B is 3. 12 by 2, 6. All right, students. Next is coming up is English. We'll continue physics tomorrow. But before that, I would like to say something. English Tarvata, I have got an important announcement to make. So please wait for the announcement. English Tarvata, I'll make the announcement at the end of the session. So please wait for the announcement. That's an important announcement I have to make. I don't want to miss it. So please wait for the announcement to be done. At the end of the English session, I'll do it. All right. I would like to please request Gayatri ma'am to take over. Over to you, ma'am.
Thank you very much, sir. Thank you, sir.
Thank you, ma'am. Thank you, ma'am.
Yes, sir. Very good evening, students. Hope you all enjoyed your physics session. Now let's move on to English. Yes, I'm just sharing the screen. All right. Yes. So English carries 50 marks, so we should not neglect English. All right. So today we are going to do a very, very interesting session, that is synonyms, right? So in synonyms, you have to arrange the sentences to fit in the blank. All right. So this is very interesting, in fact. So the first one, we'll do it for you. Just quickly look into the board. The availability of electric power dash in various directions. So this PQRS has to be arranged properly, chronologically as per the sentence. All right. So here, being the first one, we'll do it for you. The first one answer is PQRS. What does it mean? It means the availability of electric power. After that, the sentence would continue as would make a tremendous difference to the countryside and enable rural economy to be improved in various directions. Is it clear, students? So it's very, very interesting, in fact, but since this is little lengthy, I'll give you a little more time for you to choose the answer and select it and then put it in the chat box. All right. So how you have to do this is read the question. All right. So PQRS has to be arranged properly or chronologically, which would be the continuation of the sentence. Like here, for example, the availability of electric power dash. So what is the first and the apt sentence? The continuity of that is would make a tremendous difference to the countryside and enable rural economy to be improved, right, in various directions. So this would be a proper sentence. And this is how it fits in the blank. All right, fine. So with this note, let us move on to the second question. Most of the diamonds found dash diamonds to crystallize. So 4 options are given. Quickly read to yourself what would be the first one, second one, third one, and fourth one. All right. So are high enough to allow, where the pressure and temperature on earth were formed below the earth's crust in the upper mantle. All right. So take your time. Give me the option. Put your answers in the chat box, whether it is 1, 2, 3, or 4. All right. Yes. So I'm giving you time. Being, it takes time for us to think, because you need to put 4 options. It's not one option, isn't it? All right. So quickly think over it and give me the answer. I want everybody to answer this. Yes, answers have started coming. In fact, very nice. Okay, option 3, right? Akhilesh Reddy, check your option. Gayatri, you're absolutely right. How about others? Students, I want everybody to try. Vishwant, you're right. Bhanuth, you're right. Sai Vardhan, you're right. All right. So almost all are giving me the right answer. Let's disclose the answer. It is none other than option 3. RSQP. How? See, when the sentence starts with most of the diamonds found on earth were formed below the earth's crust in the upper mantle, where the pressure and temperature are high enough to allow diamonds to crystallize. All right. Yes. Excellent. See the next question. Computers and mobile phones dash our attention span. So computer and mobile phones, you have to arrange these 4 sentences. What comes first, next, and the last? Is it grammar and reducing are turning us into lazy writers, ruining our spelling and dash? All right, so I'm giving you time. Quickly think over it and give me your answers. All right. Yes, your time starts now, but don't take too much of time. Otherwise, we'll not be able to finish fully. I want to complete almost everything that has been scheduled for you. Okay, I think time is up. Let's slowly see the chat box. Harshita, you're right. Gayatri, check your answer. Kumari, you're right. Malesh, check your answer. Read the sentence. I'm giving you extra time because you need to read the sentence, ensure that it is making a proper sentence. Arrange the sentence. All right? Yes, fine. See, the correct answer is option 1, QRSP. How computers and mobile phones are turning us into lazy writers, ruining our spelling and grammar and reducing our attention span. All right. So what do you think about this, students? It is absolutely right, isn't it? Absolutely right. Because anything that we want to do, we forget something, immediately we go take our mobile phones, go to Google, and we Google up and then find out. So we are slowly losing the capacity to think, isn't it? So we need to think. In early days, we never had mobile phones or computers, isn't it? So these mobile phones have come recently. So we need to think, apply our brain. And this mobile phones and computers should be our last resort. Finally, only you should use that. All right, fine. See the next question. Greed is regarded as dash. Okay, so greed is regarded as, give the options. The possible option is for, P, possible ruinous, and Q is because it has destructive effects, immoral behavior on the other people. Okay, so greed is regarded as dash, dash, dash on the other people. Right? So by now you must have thought over it and give me your correct answers. Put it in the chat box, waiting for your answer. Just think over it before you choose the option. Read it yourself. Ensure that the sentence is being chronologically and properly arranged so that it makes a proper sense. That is how we choose the option. All right, let me check the chat box. How many are giving me the right answer? Oh my God, almost all. Akhilesh, you're right. Shashank, you're right. Swapna, check your answer. How about others? I want Gayatri, you're right. I want everybody to be a participative session, right? Everybody should participate and give me the answer. Banut, you're right. Harshita, you're right.
The last notice.
Yes, almost all are giving me the right answer. Excellent. Let's see the correct answer. It is option 3. SQRP. Yes, so greed is regarded as immoral behavior because it has possible ruinous and destructive effects on the other people. Right? Does it make sense? Yes, it does make sense. Excellent, isn't it? Right. I really enjoyed teaching you this session, especially arranging the sentence. All right. See the next one. It is true. Dash. Seizing every opportunity. So what could be the arrangement after it is true? Four options are given. PQRS, born to be happy, but we are born that we are not to seek happiness. Yes. Quickly give me the right answer. Your time starts now. All right. So I cannot give you more than 50 to 60 seconds. That would be little more because we may not be able to cover the other questions. All right. So the answers have started coming. Yes, before I check the chat box, please read the answers to yourself. Read the answers to yourself and ensure that it is making a proper sentence. And then finally give your answer in the chat box. Yes. Let's see who all are giving me. Gayatri, you're right. Banot, you're right. Akhilesh, check your answer. How about others? I think those names all have, it started running, isn't it? So I'm not able to catch. Vishwant, you're right. Pavani, you're right. All right, let's check the key. Yes, it is. It is option 1. Many of you had given me this. How? It is true that we are not born to be happy, but we are born to seek happiness, seizing every opportunity. All right, see how beautiful this sentence is, isn't it? So we are not born, it is true that we are not born to be happy, but we are born to seek happiness. So where is the happiness? It is lying within us, isn't it? It is we who make our destiny. So every opportunity has to be grabbed by us. What an excellent and beautiful sentence. All right, let's move on to the next question. Indiscriminate industrialization resulted dash of opportunities. So 4 options. P says as the rural. Q says in cities in search. R says in urban migration. S says poor settled. So 4 options, arrange it in proper order. Is it option 1 PQRS? Is it option 2 SRQP? Is it option 3 RPSQ? Or is it option 4 PSRQ? All right, students. So read the sentence. Of course, you can use your pen, your notebook or whatever and make the answer correct. All right. Yes, your time has already started. And let's see how many are going to give me the right answer. All right, I'm opening the chat box. Okay, Banut, you're right. Mitra, you're right. Akhilesh, check your answer. Akhilesh, check your answer. Abhiram, you're right. All right, no Akhilesh. Sai Vardhan, you're right. Let's see. The answer is none other than option 3. Many of you had given me this option. Yes, perfect. RPSQ, how? Indiscriminate industrialization resulted in urban migration as the rural, poor settled in cities in search of opportunities. All right. Yes. So this is how this question has been framed. Right. So excellent to those students who have given me the right answer. Keep it up. And with the same spirit, let's move on to the next question. The transition from dash without expectations. So 4 options are given. School to college, meet it. So 1 must is demanding. So which is the right answer? Is it 1, 2, 3 or 4? All right, so this is also very simple. Read the sentence, arrange it, read it yourself, and then you'll get a very good clarity. And then you can give me your answers, put it in the chat box. Almost all the answers are just coming. Let me check the answer. Gayatri, you're right. Malesh, check your answer. Geeta Devi. Okay. Agnivesh. Agnivesh, you're right. Sai Vardhan, you're right. Shruti, you're right. Okay, all right, all right. I'm not able to read all names. Almost everybody has given me the right answer as option 2. Good. How? The transition from school to college is demanding. So, one must meet it without expectations. All right. So, when we move from school to college, so how is the transition? So we are expected to perform more, isn't it? All right. See the next question. The railways have launched dash on a real-time basis. So 4 options where one can find on a Google map, an online application, the exact location of 6,500 trains. All right. Yes, that's not the order actually. I'm just reading how it goes like PQRS. All right. Let me see how many are going to give me the answer. I'm giving you a little more time so that you can arrange it properly, sequentially, chronologically, make it into a proper sentence. All right. Your time is running. Let's see how many are able to make it. Yes. The challenge is to get the correct answer, students, not to give your answer first, but to make it correct. All right, let's see the correct answer. How many are giving me the right answer? Okay. Before Sai Vardhan, somebody give me the answer. It is right. Sai Vardhan, check your answer. Vishwant, check your answer. Banot, you're right. All right, almost all are giving me the answer. Vishwant, you're right. Almost all are giving me. But the correct answer is option 3, RPSQ. How? The railways have launched an online application where one can find the exact location of 6,500 trains on a Google map on a real-time basis. Yes. So does it, isn't it? It makes sense, isn't it? Yes. Excellent. It's perfect. And that was a pretty simple sentence as well. Let's move on to the next question. A man is born alone, dash, his actions alone. So 4 options, good and bad. He experiences the and dies alone and consequences of. Right? So 4 options. Is it option 1? Option 2, option 3, or option 4? So quickly think over it and give me the answer. This would be the last category or the last model of question which comes in the arranging the sentences. All right. So after this, we'll have a one word meaning. All right. So quickly do this and give me the answer. Almost time is up and the answers are coming. Yes. Banut, you're right. Sai Vardhan, check your answer. Vishwant, you're right. Malesh, you're right. Akhilesh, check your answer. Honey, check your answer. Gayatri, you're right. All right. Almost all are giving me the answer. Yes, but the correct answer is option 2, RQPS. How? Look at the sentence formation. A man is born alone and dies alone, and he experiences the good and bad consequences of his actions alone. Yes. See, what a beautiful sentence. So today all heart-touching sentences are coming, isn't it? So when a man is born, he's born alone, isn't it? And when he dies, he goes alone. And in between his birth and death, what is that he experiences? Whatever is his actions, if it is good or bad, whatever is that, the consequence of that, the result of his actions he experiences. All right, with that note, let's move on to the next category. Only one word is correctly spelled. Identify the word. Yes, this is yet another very interesting session. So 4 words are given. So you need to choose the exactly properly spelt word. Spelt word means proper a word which has correct spelling. Okay. So spelt word is proper spelling. It may look all 4 are right, but there is a difference. All right. So your first word is mandatory. Your second word is circulatory. Third word is temporary. And fourth one is regulatory. Right? So you need to know mandatory is TORY, circulatory is TORY, regulatory is TORY, but temporary is right. That is why your correct answer is temporary. Option 3. All right, students. Doesn't it sound very interesting? Yes. Right. See the next question. 4 words are given. If you are very good in spell bee, probably this you will do it within a second. Right? Fine. So the first word is convenience, initiative, concessional, exaggerate. Very abruptly or very neatly, you can see that among the 3 words, spelling is wrong. There's only one word where the spelling is right. Let's look into the chat box and see which option. How many are going to give me the right answer? Yes. Gayatri, you're right. Banut, you're right. Vishwant, you're right. So I think students, you all are very good in spellings, isn't it? Yes. So this shows that you're very good in spellings. Yes. Option 4 is right. Exaggerate. Convenience, E should come. Initiative, INITI. Right? So concessional, one more S should come. And exaggerate is perfect. All right. So you need to identify the correctly spelled word. So before you identify, please look at the question. Sometimes your question may be, there is one incorrect word. So identify that. So even that could be your question, isn't it? All right. With this, let's move on to the next question. So you need to identify the correctly spelled word. First one is dialogue, giraffe, scissors, humorous. Right? Dialogue, giraffe, scissors, humorous. I don't think this requires any time for you, isn't it? Okay, I think I've given you enough time. Let's see. Vishwant, you're right. Gayatri, you're making mistake. For giraffe, E should come. Before Malesh, I'm getting one answer. I'm not able to see the name. Geeta, you're right, Geeta. Perfect. Banut, you're right. All right. So almost all are giving me the answers. And the correct answer is scissors. Right? So dialogue, giraffe, E should come. Humorous spelling is wrong. HUMOROUS. All right. Yes. See the next question. So correctly spelled word has to be identified. Duration, duster, electricity, economical. Okay. So very easy. In fact, I'm sure many of you would have started giving me the correct answer. Let's see the chat box. How many are giving me? Abhiram, you're right. Malesh, you're right. Geeta, you're right. Gayatri, you're right. Almost all. I'm sure it's very simple. So everybody must have quickly and correctly identified. Duration is right. Duster spelling is wrong. Electricity is wrong. CI. Economical. ECONOMICAL. Okay. Right. See the next question. You have 4 words. Assiduous, nefarious, macabre, loquacious. Right? So, many words you would not have understood. So, let's do it for you. Nefarious is the correctly spelled word. Yes, see the next question. Cortege, damage, mileage, plumage. Yes. So very protrudently seen that 3 words are not properly written with correct spelling. There's only one word which has proper spelling. Let's see how many are able to give me the right answer. Abhiram, you're right. Swapna, check your answer. Ramcharan, check your answer. Gayatri, check your answer. If you want, you can quickly use any other reference books for time being. Try not to use. If required, you can use it. Chaitanya, Swapna. All right, all right, all right. The correctly spelled word is cottage. Okay. Damage spelling wrong, mileage spelling wrong, plumage spelling wrong. See the next question. Restaurant, 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 restaurant. Okay. So don't tell me, ma'am, we really forgot the spelling of restaurant. You should not forget. You should be very staunch saying that, ma'am, this is the correct spelling. Okay. Right. Let's see how many are giving me the right answer. Sai Vardhan, you're right. Jnaneshwar, Ramcharan, give me the option, students. If you write the word, it is difficult for me to read because the names are running. Almost everybody are giving me the answers, isn't it? So give me the options, which should be easy for me to check whether your answers are right or wrong. Yes, Hanish, you're right. Yes, Banut, you're right. Geeta, you're right. All right. So almost all are giving me the right answer. It is none other than restaurant. Restaurant. All right. See the next one. So the only one word which is correctly spelled is incidentally, 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 or incidentally. All right. So the way I spelled would have really made you to understand the correct pronunciation, the correct spelling. All right. Let's see how many are going to give me the right answer. We are running absolutely out of time. So Gayatri, you're right. Banut, give me the option. Please don't write the word. Okay, Banut, you're right now. Swapna, you're right. Chaitanya, you're right. Almost all are giving me the right answer as option 3. Perfect. Incidentally. Yes, so there is one clue how to learn the words, students. When you find any difficulty in learning one particular big word, break the word into many or maximum parts. Okay, then learn it by heart it, then you will get the word. Okay, here for example, in C, dent or dentally. Okay, so it is up to you to break the word and then do it. All right. See the next question. Profession, 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 or profession. Okay, it should be profession. So what is the correct spelling of that? Quickly give me your answer. I cannot give you much time for this. Okay, option 1 is not right. Banut, you're right. All right, let's see. After that, many are giving me the right answer as profession. Profession. See the next one, ordinance. So for ordinance, which is a correctly spelled word? Is it 1, 2, 3, or 4? Quickly identify and tell me. Let's quickly do it and try to complete this. So let me go with the answer. It is ordinance. Ordinance. Right? So you would have learned this in your civics, isn't it? Yes. See the next one, that is political science. Sparrow. So which is a correct spelling for sparrow? Let me check the chat box now. Yes, second option. Almost all are giving me the second option. Excellent. Good. It is Sparrow. All right. See the next one. Occasion. Which one? Is it 1, 2, 3, or 4? So often we get confused with this, whether it is 1S or 2S, or whether it is 1C or 2C, isn't it? So let's see now whether children are getting confused or going to give me the right answer. Akhilesh, check your answer. Banut, you're right. Sai Vardhan, check your answer. Malesh, you're right. Gayatri, check your answer. Always only one letter can be spelled twice in most of the words like this. All right. So the correct answer is occasion, option 2, Occasion. All right. See the next one. Concealment, containment, confinement, or consignment. Very simple. Only one word is right and properly spelled. Okay, so let me disclose it. It is consignment. Consignment. All right, see the next one. Achieve, apparently, beginning, business. So among this, which is the correctly spelled word? Is it achieve? Is it apparent? See the question? Only one word is misspelled. Okay, see, that's what I wanted to highlight. Not all the time your question will be identify the correctly spelled word. See this one, your question says only one word is misspelled. Identify the word. I was really wondering because many words were correctly spelled. Then only I looked into the question. All right. So students, we should not make such mistakes. So read the question properly and then let's give the answer. So only one word is misspelled, right? And it means that only one is not having proper spelling. All others are right. Which one is it? Is it achieve, apparently, beginning, or business? Let's see how many are going to give me the right answer. Sai Vardhan, you're right. Banu, check your answer. Gayatri, you're right. Sandhya, you're right. Yes, almost all are giving me the right answers. Answers are coming now. It is achieve. So ACHEIVE. No, the answer is ACHIEVE, isn't it? So that's a correct spelling. Here it is being spelled wrong. See the last one. So only one word is misspelled. So only one word has a wrong spelling. Which one is that? Abundance, acclaim, absence, advertisement. All right. So this is little confusing. So think and then give me your answer. Let's see how many are going to give me the right answer. Yes, Malesh, you're right. Banu, you're right. Sandhya, you're right. Gayatri, check your answer. Sai Vardhan, you're right. Yes, perfect. So excellent that you all are, most of you are giving me the right answer. It is absence. Sometimes, we'll have a confusion whether it is C or yes. All right. Excellent, students. So I'm sure you would have enjoyed the session, but definitely I enjoyed this session. Fine. So let me hand it over to Chandrika ma'am. Chandrika ma'am, it's yours. Thank you, students.
Yes, ma'am. Thank you, ma'am. Yes, students, I hope all of you have understood today's class. ఎప్పుడప్పుడు చెప్పింది ప్రాక్టీస్ చేయండి. క్లాస్ అయ్యాక కూడా ప్రాక్టీస్ టెస్ట్ ఏవైతే పంపిస్తున్నారో అవి రాయండి. అండ్ yes, now I would like to hand over to Arun sir.
Thank you, ma'am.
Yes, sir.
Hello, students. నేను చెప్పాను కదా అనౌన్స్మెంట్ ఉందని, ఆ చిన్న అనౌన్స్మెంట్ చేయడానికి మరి I came back. Students, look at the situation, students. What we've got is, imagine మీరు జాబ్ లో వెళ్తారు. After studies, after you complete your studies, get into the job in some company. All right, మీకున్న ఎక్సైట్మెంట్ కి, ఉన్న ఎనర్జీకి, you'll definitely get into some good company. But all employees do not get promoted to higher positions, right? Now, what do you think is the factor? ఎవరికి ప్రమోషన్ తొందరగా వస్తుంది, ఎవరికి ప్రమోషన్ నాలెడ్జ్ సేమ్ ఉంది అనుకుందాము. లెట్స్ సే వి హావ్ two students who got same knowledge, బట్ ప్రమోషన్ ఒకదానికి వస్తుంది, ఇంకొకదానికి రావట్లేదు, అంత ప్రమోషన్ రావట్లేదు. వాట్ యూ థింక్ ఇస్ ద రీజన్? What do you think is the reason, students? Let me reveal the reason, students. Excellent, Gayatri. That's absolutely right. Communication, she got it right. Yes, yeah, that's one of the reasons. But let's look at the most common reason is public speaking, students, communication skills. Students, knowledge is not enough. Knowledge gives you leading edge. And the knowledge antaru, it gives you leading edge over others. But you should be able to express your knowledge. You should be able to communicate your knowledge. Where you telvali meeku enta knowledge unnadi. Only then you will be able to stand and be appreciated among a group of people. Now, what is public speaking basically is this, students. It's a skill that you need to express your opinion in structured manner and in a very interesting way, so that others listen to you and understand what exactly you want to say. మీరు ఏం చెప్పగా అనుకుంటున్నారో అది వాళ్ళకి అర్థం కావాలి. They should listen to you when you speak. The people should listen to you. Yes, okay, that's absolutely right. Communication and behavior, excellent. So you people are on the right track. I think you could tell us what is required for this one. So we have come up with a program. to help such students to develop communication skills, we are launching an online summer camp, students. Online summer camp, the best part of the camp is this, students. It's spoken English and public speaking camp. The best part of the camp is the fee structure. Fee structure, yes, Abhiram, excellent. Cyber, excellent. Yes, you people are thinking right, but only thing is, if we develop your public skills, your spoken English skills, you will be able to, you'll be in a better position to speak and communicate your ideas to the other person. Knowledge chala baagundi. Your communication skills might be good. I'm not commenting on that, but there is always a room for improvement. Communication skills enta baagunna kuda inka baa chesukovachu. You can better always better yourself, so that one day you can become better than the best. Right? The best part of this one is ilanti spoken English inka public skills meeru online search cheste, they will cost you around 12,000 to 40,000 bucks, students, rupees. But we are offering for 600 or 1,000 rupees, 600 to 1,200 range lo offer chestunam. Look at the price range, and you'll get a very quality alane untundi. All right, and personal care and communication alane untundi. But look at the price range. We are intending to help rural students, so that's why we are introducing such a camp. All right, students చాలా మంది IITs లో వెళ్ళారు, బిట్స్ లో వెళ్ళారు. ఇప్పుడు మీకు గాయత్రి మేడం చేసిన క్వశ్చన్స్ బిట్స్ లో వస్తున్నాయి. బిట్స్ లో ఎగ్జామ్ ఇంగ్లీష్ కూడా ఉంటుంది, మ్యాథ్స్, ఫిజిక్స్, కెమిస్ట్రీ ఉంటుంది, ఇంగ్లీష్ కూడా ఉంటుంది. If you are not good at English, you cannot get into bits. Bits is one of the finest. Yes, Abhiram. Yes, there is a fee for it. Very nominal fee for 30 days. For 5th May to 31st May, we are just charging 600 to 1,200 rupees. Screen మీద ఉంది చూడండి, క్యాంప్ ఉంది. Interested students, మీరు క్యాంప్ 9642215226 కి కాంటాక్ట్ చేయండి. Alright, you'll get more details about it. మీకు వాట్సాప్ లో కూడా పంపిస్తాము, సేమ్ బ్యానర్, సేమ్ ఫ్లైయర్. మీకు అక్కడ చూడొచ్చు, మీరు చూసి డిసైడ్ చేయొచ్చు. If you register before 30th April, you got a 40% discount. So I suggest you register before 30th April so that you can avail the 40% discount, students. It starts from 5th of May. Yeah, sure. Abhiram will definitely send you the WhatsApp also. Don't worry about it. But before 30th of April, if you register, you got a 40% of discount. I suggest you avail the discount. All right, students. That's all for today. Tomorrow we'll again meet at 7:30 p.m. Please join by 7:25 itself. Good night.